Flue Gas Composition, Excess Air Optimization, Part 2. The major components of the flue gas are oxygen, carbon dioxide, carbon monoxide, and unburned hydrocarbons. This is the same diagram as shown in previous slide, but little bigger in size for your reference. In this diagram you can see that when it is condition of complete combustion, then we can see that the excess air is about this portion of the graph, and when this excess air is of this amount, we can see that carbon monoxide goes almost to zero, combustible fuel or the unburned hydrocarbon goes almost to zero. The percentage of oxygen is at reasonable value, and carbon dioxide is at its maximum value. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. The attached figure shows the composition of the flue gas as a function of the amount of air present. The combustion process is usually operated so that enough air is provided to convert all the fuel into carbon dioxide, but not much more. The figure shows the theoretical relationship between load and excess oxygen. The same figure as in the previous slide, but little bigger in size for your reference. This percentage of excess oxygen is not a constant. It varies with boiler design, burner characteristics, fuel type, air infiltration rates, ambient conditions, and load. The attached figure shows that the percentage of excess air must be increased as the load drops off. This is because at low loads the burner velocities drop off and the airflow is reduced while the furnace volume remains constant. This reduces turbulence and lowers the efficiency of mixing between the fuel and the air. This loss of mixing efficiency is compensated for by the higher percentage of excess oxygen admitted at low loads. The figure shows the test-based relationships between load and oxygen. The same diagram as shown in the previous slide, but little bigger in size for your reference. The curve shown in previous slide theoretically illustrates the relationship between the excess oxygen requirement and load, and the attached plot provides actual test data for a specific boiler. Because each boiler has its own unique personality, this relationship must be experimentally determined. Once established, it can be used with a fair degree of confidence, although small shifts are still likely to occur as the equipment ages. Request: it is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। बहुत जल्दी यह लेक्चर आपको हिंदी में भी मिलेगा।